Assalamu alaikum everyone. I am Fatematul Johra, a student of Department of Economics at Shahjalal University of Science and Technology, Sylhet. Today I will be presenting on quantitative risk analysis and volatility modeling. Uh, in this presentation, I will discuss how derivative contracts are mapped for risk assessment, compare critical risk metrics like value at risk and expected shortfall, and demonstrate the practical application of the EWMA and GARCH volatility models. Let's move into the core analysis. So we begin with question 22.7, which explored the structural mapping of forward contracts for VAR calculation. A forward contracts to sell foreign currency involves two specific obligations at maturity. Delivering foreign currency and receiving domestic currency. To calculate risk accurately, we treat this as a portfolio of zero coupon bonds. A short foreign forward is mapped as a short foreign zero coupon bond because it represents a future payment obligation. Conversely, a long domestic forward is mapped as a long domestic zero coupon bond. By doing this, each cash flow is treated as a standard instrument, making it possible to calculate the overall portfolio risk. So next, in question 22.8, we look at the distinction between value at risk and expected shortfall. So here bar serves as a threshold point. It tells us that losses will not exceed a certain value with a specific probability, which is denoted as alpha. However, bar is often criticized because it ignores the tail risk, or what happens when things go truly wrong. This is addressed by expected shortfall. As you can see from the notation, ES is equals to expected loss given loss is greater than VAR. Here ES calculates the average loss in those extreme scenarios that exceed the VAR threshold. While VAR identifies the boundary, ES quantifies the severity of tail risk. Now let's apply this concept to volatility estimation. In question 23.7, we update the daily volatility for the USD exchange rate using EWMA model. With a decay factor lambda of 0.9, we first calculate the daily return UN, and we find the result is 0.0048. We then update the variance by weighting the past variance by 90% and the new return by 10%. That means 0.1. This gives us a new daily volatility of approximately 0.498%. The interpretation here is significant. A high lambda value indicates that the model is highly persistent, meaning it places more importance on historical trends than on sudden daily fluctuations. Finally, question 23.8 looks at the GARCH 11 model applied to the S&P 500 index. Unlike EWMA, GARCH accounts for mean reversion through the parameter omega. Given an index move from 1040 to 1060, a high persistence parameter beta of 0.92, the return is calculated as 0.01923. The variance update formula yields 0.00011614, and the updated volatility estimate is 1.078%. In conclusion, we see the volatility has increased. This is a result of both a significant market shock and the high persistence inherent in the Garch model. Thank you for your time.